All right, so the next session is one that I'm also really looking forward to. We have a fireside chat, and it's going to be the Tesla story, perspectives from the CTO and a VC. And just to say a little bit about who'll be participating, we have Ira Ehrenpreis with Technology Partners. He's been with the firm since 1996 and leads the company's clean tech investment practice, investing in energy technology, water technology, and advanced material opportunities. He's a recognized leader in both in the venture capital industry and clean tech sector, and in 2007 was named one of the most 50 influential men under 45 by Details magazine. In the venture community, Ira has served on the board and executive committee of the National Venture Capital Association and on the board of the Western Association of Venture Capitalists. In the clean tech sector, he's served on several industry boards, including Department of Energy's Efficiency and Renewable Energy Advisory Committee, NREL's Laboratory Advisory Committee, and also the Clean Tech Investor Summit. He's also very active around Stanford University, and we're very appreciative he agreed to be the other person in the fireside chat. And the other person that we're going to get to hear from is J.B. Straubel, again, someone that we're very proud of, a Stanford graduate, who is one of the co-founders and chief technology officer of Tesla Motors. Today he's responsible for all software, electronics, propulsion across Tesla's portfolio, with operational responsibility for roughly 1/4 of the company. This includes all aspects of powertrain R&D, engineering and production. And the propulsion performance of the Model S has been one of the determining factors in awards such as the 2012 Motor Trend Car of the Year by a unanimous vote. I will say I got to ride in one last Friday over at Tesla, and it was really exciting. Better than the roller coaster, and I like roller coasters, so it was really great. So JB's passion for electric vehicles began at a young age, starting with rebuilding electric golf carts at the age of 14, and converting a Porsche 944 that held the world's electric vehicle racing record. So long history of interest in this. He, as I mentioned, is a Stanford student, and illustrative of Stanford's flexibility and responsiveness to his students. He described to me how basically he crafted a major of his own in energy systems engineering and integration. So with that, I'd like to welcome both of them for a very interesting talk. Thank you.
Thanks, Sally. I really want to congratulate you, Richard, the entire GCEP team, in hosting really a phenomenal event today, but more importantly, for really becoming not just one of the key epicenters of energy research here on the Stanford campus, but arguably in the world. So really terrific work that you guys have done at GCEP. In many ways, as I think about GCEP and Tesla, the stories really mirrors one another, really taking next generation research, combining it with true corporate applicability that Dick was referring to, and really ushering in the next generation of our energy economy. And I think Tesla's done a phenomenal example of that, and that's really, Sally, what you and the GCEP team work on every day as well. Sally mentioned that JB and I are both alums. It's great to be back. It's always terrific to be back on campus here. And I want to use this opportunity to really thank JB for the tremendous contribution he's made to Tesla. As an early investor and board member, I've had the opportunity firsthand to watch the passion, the dedication, the real innovation behind the JB mind. And really, he's just, the company would not be where it's at without him. And I want to just tell you thank you very, very much for the entire world and for Tesla as a whole.
Thank you, Ira. Well, likewise, I should thank you and the role that you guys have played in being, strong supporters for us. And sometimes when it was not obvious, and there were plenty of times when putting more money into Tesla, was not seen as the logical move by the whole investment community. So you guys had a strong part in the success.
Thanks, JB. Well, with that, let's actually see what Tesla's doing these days. So JB, I want to start, we look at Tesla today, we see a video like that. In the last year, Tesla's become the 2013 Automobile of the Year. Consumer Reports ranked it the highest car it's ever rated. NHTSA just came out and had it the highest safety rated car in history. But how'd you go from Stanford, from when we got involved when it wasn't much more than a PowerPoint, to producing what we now see in this video?
Yeah, it's been quite an adventure, kind of a roller coaster in its own right of just building the startup and building the products. But I think one of the key things that was important all along the way is that we never took our sights off of just building the very best car that we possibly could. And we set the metric of building the best car in the world. Yeah. And that was this phrase that we repeated in every meeting, at every discussion along the way. And it kind of seems ridiculous, but after you say it, a dozen times, 100 times, it starts to sink in, and you just sort of realize, well, that's our bar. That's what we're trying to do, best in the world. Not just the best electric car, but the best car out there. And that took a lot of time, of course. That took several years, and that's why Model S, was such a major project.
Yeah. When I see some of the GCEP research that gets me very excited, how do you think about going from that initial formation of an idea, the early stage idea that we see in a lot of GCEP programs, to the kind of commercial success that Tesla's become? What kind of advice do you have for folks out there working on other things?
Well, I think in the early days of Tesla, we did something that was maybe a bit unique. We looked at the very long-term trends.
Right.
And where we thought the industry was going over decades, not just a couple years, not what was trendy and exciting at the time. And actually batteries and electric cars were not at all trendy at the time. They were kind of seen as crazy and yesterday's technology. But we looked at where battery technology could go over decades to come, and where the environmental issues around transportation and greenhouse gas per mile. And there were a lot of trade winds blowing in the direction that we wanted to go. So that's how we made some of our early decisions of what research we would focus on and how we would make practical bets around a product that leveraged where things were headed, not where they were today.
Well, it's interesting. When I look at a lot of the GCEP research, there are some things that are very aspirational and in some cases non-obvious. And when I think of the non-obvious part of this story, it was right around the time the Prius was really gaining traction, and everyone said hybrids are going to take over the world, and it was clearly a time no one thought EVs stood a chance. That was a pretty maverick decision.
Yeah, it definitely went against the flow, and actually fuel cell vehicles were a big point of focus around the time Tesla was started, and we looked at the economics fundamentally of a fuel cell pathway for transportation versus battery electric, and just felt strongly that battery improvement and the energy efficiency of going all the way from a primary energy source through to the vehicle was going to win with batteries. Yeah. And we're well on the way, I think, to demonstrating that can be possible, but it's still just a tiny drop in the bucket on how much scaling is left to happen. Yeah.
And so for people who are thinking about areas to focus on, talk about that maverick notion of seeing beyond the status quo, the incumbency, the trends du jour, but instead you really did focus beyond what I think most thought was incumbent and popular.
Well, I think, for a student or people getting into research, I think the first thing is, to follow what you find fun. Don't necessarily just try and follow the biggest, mega trend that looks like it's going to be profitable, but, find what you're incredibly passionate about and, will persist in, doing even through really difficult times. And then if that lines up with where an industry is going, and I think the case of what we're involved in, energy storage and renewable energy are the two issues that are going to be with us for decades and decades to come. Yeah.
When I think of JB's and Tesla's success, the real story I think behind it includes a number of factors, but one of the key ones for me is that persistence and tenacity. And it's easy now to talk about the success. It's easy now to watch a video like that or to hear about the accolades and awards. But this is a company and an individual that stared death in the face many, many times. This was a company on the brink of failure many, many times. And what you and the team did to navigate through that is often the difference between that success and failure. I think it's important to talk about some of that as other people out here are navigating their own challenges and figuring out how to get through their own difficult stages.
Yeah, it's a great point. No startup is a straight track, or very few, or straight tracks from founding to success. And we certainly had our share of really scary times, whole periods in the company's history where it felt like things were on the brink and we weren't sure there was going to be a company a few months later. But that was really where we had to have strong
so what
conviction.
You did to get through it?
Super strong conviction in what we were doing, and knowing that it was the right thing to do, and being able to sort of drag yourself out of bed in the morning and go fight the fight again, one more time, even though the outcome might be a little bit uncertain. But I think we were really quite confident all throughout the company that what we were doing was valuable and the world needed it.
You didn't just do that, you also convinced others of that as well. And again, against the grain, part of building a business or building a success is really bringing others into the fold as well. And you've done a phenomenal job doing that.
It was a hard part of the building of the company part. People forget that it's not just engineering a product, but along the way we're building a team, we're building a collection of customers and passionate followers. And I think Tesla has been very fortunate to have an amazing base of customers that really share this excitement and passion about the product, the market space, and finding ways to use more renewable energy in their life and emit less CO2.
So much of the success stems from the innovation side and really the innovation that you've spearheaded. I want to talk about multiple aspects of the innovation piece. First, let's talk about the innovation behind Tesla. And then I actually want to talk about broaden the discussion beyond Tesla, talk about some of the things that GCEP's doing and other things that you might find interesting. But let's start with Tesla. What were the kernels of innovation that began, and how have those innovations evolved?
Well, historically, the biggest innovation that we focused on and was quite enabling was the battery technology. Tesla was the first company to commercialize lithium-ion batteries for transportation applications. And there was a lot of learning, a lot of difficult engineering that went into that, all the way from ensuring capacity over time and the lifetime effects, ensuring power and getting the range that we needed with good efficiency. Last but not least, safety. We spent an enormous amount of time, architecting safety systems, and that was difficult because, in the early days, especially, and even still today, there isn't a good safety landscape or regulatory landscape around some of these things. So we had to kind of figure out what were the right bars and set our own metrics.
When you think about designing from the ground up, you used what many thought was a weakness, the battery, as a replacement for the internal combustion engine, and you ended up using it as a design and safety strength. Talk a little bit how you did that.
I think it's just approaching it from a different angle. Most existing vehicle manufacturers today have had a 100-year history of building gasoline vehicles, and they're extraordinarily good at it. It's well optimized. There's multiple teams designed to make a phenomenally good car. But when a new technology comes in, like a battery electric vehicle, it typically gets viewed through the lens of a gasoline vehicle. Right. We didn't do that. We started from scratch and said, here's a new set of technologies that we're going to make the best car in the world out of. And we kind of threw away all the convention and then saw what the opportunities were.
Yeah.
We didn't view it as something that was trying to fill a market niche that gasoline couldn't fill. We looked at it as, how can we do everything gasoline does and more?
And so talk about the crumple zone and literally how you use that as your strength.
Well, I think as we architected the car, we put the battery in a place in the floor of the car, below the entire occupant cabin, that freed up the front and rear of the car. So the entire front that would normally be occupied with an engine is allowed to be engineered as a really ideal crash structure. Indirectly, that's what contributed to getting this best in the world safety rating and 5-star across the board safety rating.
Right.
That was directly relevant and descendant from having the battery put where it is.
Absolutely. What started though with battery innovation has evolved to so many other areas of innovation that you're leading at the company right now. And I think as I look at some of the successful companies out there, whether we talk about Google beginning with search and migrating to other areas, or we can talk about any of the major companies out there that started as a very small company as you did, it began with one area of innovation and then really mushroomed into so many others. And right now you're in that mushrooming stage. Talk about other areas that you're focusing on.
There's a ton of exciting stuff going on. I think it stems from just building a culture and building a team that loves to innovate. And Tesla was very passionate about building the best of the best team.
Right.
It was very fortunate to be here in the Bay Area. We could recruit tons of great talent from the universities, Stanford, Berkeley, and many others.
I got to pause right there. Not just Stanford.
Berkeley.
No, but not just Stanford, but from actually from the GCEP program.
Good point.
Right?
We, in recent years, it's been phenomenal how many new hires have actually had some component of their education either funded by or molded by what GCEP has done. Just last week, literally, we were meeting with a group of some of Sally's students and also some Tesla engineers, and I didn't even realize it, but a few of the Tesla engineers were saying, well, yeah, actually, my graduate research was funded by GCEP. So it's, I think, helped a lot of people stay in the energy community when they may have otherwise struggled to find funding or drifted into other fields, and
well said.
That's pretty exciting.
Well said. All right, let's go back. So the other areas of innovation.
So there's many exciting things happening. Part of the excitement is that we're going into a space that's just wide open.
Yeah.
One of the coolest things that I'm excited about is supercharging.
Yep.
And the way that we're sort of reinventing and reimagining the infrastructure of how vehicles take long trips and how energy makes its way from the grid to the vehicle.
Right. So one of the critiques of electric vehicles has always been range.
Yep.
And range now Model S about 250 miles depending on how one drives it. And that's great for daily driving and even multiple daily driving, but you go on those long trips. One of the critiques is, what do you do? What if you want to go to Los Angeles? So your answer has been supercharging. Talk about what the innovation is and how long the charge is.
Well, I think it was realizing and looking at the whole scope of the problem from a very big picture. And there's a lot of companies trying to attack infrastructure at kind of the microscopic scale. And we looked at the whole market and said, what is the problem really? It's not how do I get more than 200 miles around my house. Mm-hmm. It's how do I take a road trip, and how do I have this sort of American freedom idea that I'm going to hop in my car and drive across country at moment's notice, even though almost nobody does that.
Yeah.
But still you want to believe you can.
Right.
So that's the problem we're trying to solve. How do you go 5, 6, 7, 800 miles in a single day?
Right.
That requires rapid charging at very, very strategic and pinpoint locations. Mm-hmm. So what we did is have a concept of corridors and routes, and we looked at the major population centers and said, well, people don't just drive at random across the whole area. They follow the main routes and corridors. And if you have a range that's already a few hundred miles, you can look at how many stations you need, and it's a very, very small number.
Sure.
It's not tens of thousands. It's actually a few hundred stations if they're in exactly the right places between cities. So that's been how we attack this problem.
So version 2 of the supercharger network is how fast?
So we can get back about 50% of our entire charge in about 20 minutes.
Right.
So it's roughly 2 to 3 hours of driving in 20 minutes.
Right.
So for instance, like a trip from San Francisco to LA, you could do the entire trip and stop for 20 to 30 minutes in the route to make it happen.
Stop at Harris Ranch, get a quick bite, a drink or something, and keep moving.
Yeah.
So that's the supercharger side. We talked about the battery side. How about the manufacturing side?
Manufacturing is an underappreciated part of especially clean tech. It's one thing to kind of invent and come up with a product. It's quite another to figure out how to make it efficiently and at the right cost and scale. So, over the last 5 to 6 years, that's been a huge part of our engineering is manufacturing engineering. Yeah. Engineering the automation, the production processes, how does the line link together? Today we do most of that here in the Bay Area, in the Fremont plant across the Bay. And Tesla is quite vertically integrated because of that. I think we realized early on that in order to succeed, we would have to figure out ways to do this efficiently ourselves. And the innovation on manufacturing was as critical, arguably more so than even the product itself.
I thought Dick's practical advice of really thinking about innovation for how you get commercial and high volume is very sound advice. It's clearly that the design aspects of what Tesla's done during its path was always cognizant of it's not good enough to do it in the lab. It's not good enough to produce one. That's not what the mission is. It's about how to do high volume. And so many of the design characteristics you've had have been with that mindset. Mm-hmm.
I think a lot of times people think of manufacturing as kind of the dirty end of business, and that's just going to ship it to Asia or something. And I think we view it much more as a technology problem. It fundamentally is a technology problem. How smart can you be about reducing the process cost and rearranging all the components that go into the car in the most efficient way?
Yeah. Let's talk about just how you launch. I mean, as people are thinking about launching their own businesses, I think there's some real similarities between the path that Solar's had and the specific business model that Tesla's had, in that at one point the cost was quite expensive. It was only through time and innovation that the cost came down and led to that demand creation. And similarly, Tesla's had a path of taking a very high price point and using that as proof points to over time create different vehicles. It might be helpful to talk about that business model.
Sure, it's we get a lot of people asking us, when are you going to make the car for everybody? When is the everybody car coming? Right. And it's a bit of a misunderstanding. I feel like we're basically attacking the market where the technology can succeed the best. Mm-hmm. And in the beginning, electric vehicles have a great competitiveness at high torque. Right. It's something they can deliver at high torque, high performance at a very cost-efficient point. And electric vehicles, a little bit unlike solar, have a more there's a more emotional connection to it. There's some emotional connection to solar panels and the clean electrons that they'll create, but it's not quite as strong.
I've seen Dick hugging those solar panels.
But with cars, people really fall in love with it. They want to have it be an extension of their personality, and it's something that's really exciting to them. So that's why we started changing mindsets and really making electric vehicles, the technology, the whole market set, trying to make it cool and make it something that was desirable, fun, exciting. And I think that's really worked pretty well. Yeah. The Roadster was key in that regard.
It's true. I think that for those of you who actually have done work with Andrew Sharman and some others I see here, the notion of thinking different has always been something that we've held in high regard of the great companies out there. And really, you've done that, thinking different. The business model, thinking about electric cars, and you've also done it with the sales and distribution model.
Yeah, sometimes it's painful. We seem to think different on every single metric of the entire business plan. And you could argue maybe it was sometimes too much, but if we can hold it all together, and we have, it's been very valuable. Right. And each one of those different elements of the business plan has incredible opportunity in the long term. So we do direct sales and direct service. That's the specific difference. Yep. The whole auto market today is a franchise model. Mm-hmm. So the major car companies and think of are actually wholesale sellers of cars to the dealers. And the whole value chain gets very fragmented, and the customer connection to the manufacturer is quite broken. Mm-hmm. And I think it's a huge disability over time. Right. You can't innovate and you can't improve the products as quickly that way.
Talk about the software side. One of the interesting things about the vehicle is I liken it to the difference between most cars we've ever driven and a cell phone. Most cars we ever have driven depreciates 10 to 15% when we drive it off the lot, and it gets relatively worse every year over time. Our cell phones, from the second we get it, we add apps, we add features and functionality. It's better than the day we got it. And you've really done the latter. Mm-hmm. Talk about that, and talk about what that means for people out there thinking about designing into the car.
Sure. It's kind of crazy to me, but the Model S was the first car, and still is the only car, which does remote software upgrades. Right. Every smartphone on the planet does that, yet there is no other car on the planet that does that. So
just pause and explain. Let's talk about what that means.
It gives us the ability, to have the software improve steadily. Right. New features can get added, bugs can get fixed. It's a constant evolution and improving product.
Right. 3 months into the car, woke up one morning, I suddenly had voice recognition to a whole set of features in the car. 3 weeks later, new features and functionality. Opens up the car doors remotely through the key fob. Every few weeks, you guys are doing software updates to make this car have new features and functionality.
And certainly there's a layer of testing, validation, and safety that have to be there to make this really work and be robust. But that's been solved, and we're not really breaking absolutely new ground there. Yeah. I think it's just a certain conservatism and kind of a familiarity with software that maybe we have, being in the region where we are. That a lot of the big car companies don't have quite yet.
That was part of what I was bringing up. There's so much research going on here where you're combining the software and hardware into that vehicle. And traditionally with the car, we've always thought of it as the hardware side. And this is opening up the ability for a lot of research here on the software side to be integrated into the automobile.
Yeah, absolutely, and it's been incredibly helpful too. We're able to be responsive to things that customers like or don't like real time. Mm-hmm. Instead of having a feature that we had to guess at when we had only minimal user feedback, we can see what 1,000 people do and how they would like to use it, and then evolve a feature set or a behavior in the right way.
Right. So before moving on the automobile and Tesla, if you were sitting out there and you were doing research, or as you're sitting in your seat, wanting new kinds of research from GCEP and others to come into you, talk about the areas of the automobile that you think still are ripe for innovation, that you'd love the GCEP team to be working on, and that you want to have people spending the research dollars to support.
There's so many exciting things. It's stereotypical, but energy storage and batteries still have the biggest leverage in the entire market. There's no other single set of technologies that has the ability to scale and to change the dynamic of plug-in vehicles generally, not just pure EVs. So I think by far that is the biggest opportunity, and the biggest single need in batteries is cheaper energy storage. So lower dollars per kilowatt hour of energy storage, without sacrificing safety or acceptable throughput of energy cycling and lifetime. Those are all kind of givens. You have to meet the sort of passing grade on all the metrics, but over time, driving down the cost of energy storage will be key. It's enabling to plug-in vehicles. It's enabling to renewables. It's a massive opportunity.
Yeah.
There's also several others. Power electronics is somewhat underappreciated, but that's also a hugely important area. How do we make more efficient switching devices? How do we build better topologies and better control of more innovative topologies that do things like soft switching or generally drive higher efficiency in that power conversion?
How about interface with the grid?
Charging kind of ties straight into that, and how we make power electronics smarter, and then over time, another area of research I think that's pretty exciting. It's not quite relevant yet, but is how do we look at making electric vehicles a smart distributed resource that can help manage the grid in the right way. Once we start to have tens of thousands of vehicles in sort of more dense utility regions, that's going to be pretty interesting.
How about wireless charging?
Wireless charging is a tough one. It's something that we've been tracking and watching. There's a couple great companies working on it. It really could use some improvements in efficiency and cost. Right now, wireless charging, inductive charging, like a transformer kind of split between the car and the ground, has about a 10% at best energy penalty to it.
Right.
So if we can come up with ways, invent ways to reduce that, get it closer to a conductive link, which is close to 100%, that'll have a huge impact.
So JB isn't just have a CTO and founding role at Tesla, but he's also a board member and one of the early supporters of Solar City. And so one of the things I love about talking with JB is he can actually expound on areas well beyond the electrification of the vehicle. So now again, put yourself out there and think about other areas, maybe not necessarily related to the ones you just talked about. What are other areas, you're out there with GCEP, ripe for research, interesting for innovations as you project out as you did for the electric vehicle? What other things do you think would be interesting to work on?
Well, particularly, I'm incredibly bullish on solar. I think the long-term future, ends up being, a largely solar-powered and largely, battery energy storage in both vehicles and distributed on the grid. But I'm a little biased on that. So, I think on solar, it's fascinating to look at the overall system cost today. And, solar, the cells and the modules are really a decreasing percentage of system cost. And to me, that sort of shows that we've almost over-focused on cells and modules and under-focused on the rest of the system. There's power electronics, again, that's a key part of that, but also some of the more mundane things. There's been so much less money that's gone into, racking and mounting systems,
right.
Or just, wiring and connections, sort of unifying a lot of the regulations and rules and permitting around this. That stuff is hugely high value, but it's just not kind of the sexy problem that people want to focus to, and I think it'll have more impact in the future.
And how about beyond solar?
Beyond solar? Well, solar is pretty far out there. I think if we can make
other areas of research that you think are interesting right now.
I think the communications infrastructure and tying information technology more completely. I don't love the term smart grid. I think it's overused, but generally, adapting more intelligent communications and control to energy storage and renewables is a big opportunity. That's a piece of what people call the smart grid, but I think there will be a lot more activity happening in that space over time.
By the way, we are going to go to Q&A, so as you're starting, before we wrap up, think of some questions that you guys want to ask in that portion of this. I want to actually tie in something that I think you did really well and GCEP has done a great job, and that's figuring out the right ways to take innovation and partner with the big corporates. And part of the success I know you've attributed to Tesla is when you convinced those three big corporates to tie on. And Daimler and Toyota and Panasonic became very important partners of ours. It was at a time, again, today may look obvious, but at the time there were a lot of other corporates that were not on the forefront of doing that and looked at those companies' decisions with a very different eye than they're regarded today. Similarly, at GCEP, I'm hugely appreciative and respectful of the global partnerships that we have. And if you're thinking about tying the early innovation with the corporate partnerships, what are some of the lessons in working with the corporates that you have that GCEP and others can learn from?
Yeah, it absolutely was critical to Tesla's development and success, and it was also very difficult. I personally spent a huge amount of time on some of those early partnerships,
did a great job.
There were. You don't get a warm reception when you're an unknown startup company trying to do a different application of technology. And I can remember huge numbers of meetings going to Panasonic and basically getting the lowest possible person they could find in the entire company, and they'd kind of put them in the conference room to humor you and then get you out of there.
Now, what percentage of business is Tesla?
I believe we're the largest customer on Panasonic Energy, actually.
That's right.
So it's and growing pretty fast from there. But it took a lot of persistence, and a lot of the bigger companies, I think, are they have to be a little bit slower to change. They can't react to every single startup that comes in the door. They'd never have any focus. But I think the only maybe helpful advice would be to find a more systemic way to kind of receive inquiries like that and try and filter what might be interesting partnership opportunity or what might be hints that the market is headed in a different direction.
All three also took very long-term perspectives, similar to the partners that GCEP has. And when we first developed those partnerships, it was A, non-obvious, and B, unclear what the timeline of really getting to fruition for those partners.
Yeah, I think in each case it was a little bit of a different scenario for us. Panasonic, Toyota, and Daimler, or Mercedes-Benz, were our three huge partners and still remain so. And we've learned critical things from each one. It's been so helpful. From Mercedes, we really learned a lot about the product development cycle. Qualifying and developing products with them. With Toyota, it was very helpful on the production process when we were starting to industrialize, and they were instrumental in we purchased the former NUMMI factory from them in Fremont,
right.
And they helped a lot on how to set that up and configure it and kind of teach us how to be an operating company.
Yep. Supply chain partners.
Absolutely, supply chain and quality and supply chain. Panasonic was the first, and was critical. We had to make it work in order to really make progress on energy storage and on the battery pack. But
then tie it into folks here who are trying to tie in with the GCEP partners and others in the ecosystem. Any advice you can impart?
Well, I think GCEP gives an interesting opportunity to bring the big companies straight into research in the academic environment, and to the extent that can be leveraged by people coming out of GCEP and launching into new companies or starting new ventures. That's pretty cool. I think it's a big leg up if you can be that much closer to companies that have a longer term kind of strategic interest in the space. We kind of had to go it on our own, and it was quite a few years and just literally flying to Japan, banging on the door, and hoping we'd get another meeting. It's far better if you can start with a relationship as part of a research group.
So I always get asked to ask this question of JB. It's clearly an area of intrigue. What about Autopilot for the car?
Autopilot. Yeah, this is a whole nother avenue of research that I think is going to be inevitable and transformational for cars. Not just electric, but it's going to happen. And we're investing quite a bit of time in this. We're hiring a large team, as some people might have seen, and I think it's going to start with increasingly independent active safety systems in the car. You won't just wake up one day and have a feature that is to sort of sit in the back seat and drive by wire. We might get there eventually, but over time, we'll have systems that can take on more and more of the sort of either mundane or just really boring or safety critical things that you need to do in the car.
Yeah.
So I think this will happen sooner than people think. It's not a matter of waiting for new sensor technology or processing technology. Actually, those pieces of technology have moved beyond where this is possible, and it's the whole industry has just been slow to adapt and slow to adopt them. Okay. Almost every other type of vehicle on the planet has an autopilot that's more capable than cars,
right?
Which is pretty amazing to me. Every airplane has an incredibly good, capable autopilot. Ships, you name it.
You don't want to mention space?
space, absolutely. You can basically fly a spaceship and dock it with the space station, on autopilot. So these industries have sort of been forced into that or done it mainly for safety reasons. They didn't do it just because the pilot was bored. They did it because it was safer. And in cars, it's amazing, but vehicle drivers are probably the least trained of all the different operators of all those vehicles. So if there's one area where an autopilot would be the most relevant, it should be in a car. So anyway, I think this is going to have a huge impact, very positive impact on overall transportation safety, but also just the time availability of people.
Right. Well, before we go to questions, I want to make sure what I really have always appreciated about the Tesla culture is always getting things out in the open. And I woke up one day last week and we had a fire. Talk about that. What happened? How did the engineering of the vehicle plan for that? Put in context that fire relative to the fires that we see globally for the internal combustion engine.
Yeah, it was an unfortunate accident. We had a Model S that was in a collision with a sort of a debris or some road trash, big metal piece of trash in the freeway. And the owner drove over it. He couldn't avoid it. And the piece of metal jammed under and put a huge hole in the bottom of the battery pack.
Lifted the car up.
It literally kind of jumped the car in the air. And it's a scary event. It's something we never want to see happen. We don't want to, obviously ever have a fire if we can avoid it. But stuff happens in the real world. Cars crash. There are collisions out there. And the challenge, I think, is that any new technology is so primed, for people to jump on any incident and kind of make it into something it's not. And the big difference here is that the car was in an accident. Right. There was a collision. A lot of the other sort of events that people have gotten very concerned about with lithium-ion batteries were sort of spontaneous fires.
Yeah, right.
There is a world of difference between having an accident and a collision, and then managing all the sort of damage around that versus something catching on fire while it's parked in your garage or on the tarmac or wherever it might be.
And then when it happened, it was engineered in such a way to protect the driver.
I hinted at this earlier, but we spend so much time on safety engineering.
Yeah.
We put in enormous amounts of systems in the car. There's hardware systems, there's software systems. We really slowed ourselves down. We actually delayed the launch of Model S, as we went through some of that and got this just right.
Yes, I remember.
And it was painful. People want you to go faster. You wonder at the time, are we overdoing it? You're looking around, some of the competitors aren't doing this stuff, and there's no regulations forcing us to do it. Right. So it's pretty tough when you're in the middle of that, because all the pressure is go fast, just make it work. Yeah. And at times like this, it feels pretty well validated, and we're really happy. The way the vehicle performed was great. From an engineering point of view, we're extremely happy with it. We have a bunch of firewalls inside of our battery system, so that if there's giant crushing damage, crash, or something in one part of it, that's the only part that's affected. Yeah. It isolates it electrically and thermally, and you don't have some kind of big surprising chain reaction. Or anything.
It was although no one ever wants to see that happen. In many ways, how the car performed should have been a very proud moment. It contained it to the front of the vehicle. It didn't get into the cabin. It gave the driver and passenger signals to get out of the vehicle. I think 5 minutes to get out, and actually the driver of the vehicle was hugely appreciative of the way you engineered that vehicle. So huge congratulations in it performing the way it did in that unfortunate incident.
And I think one final point on this one that people tend to forget or not dramatize is, in a gasoline vehicle, the outcome, can and often is far, far worse. You're carrying so much more energy that we have a fundamental leg up, almost an order of magnitude, less energy on board. Yeah. And that's a big help in these kind of, any kind of accident or damage. I would rather be driving an EV.
Yeah. So with that, let's take your questions. Let's get into what you want to talk about. Please. I don't know if there's do you want to yell it out? And there we go. Oh. Nice job. Thanks.
So let's talk about, if you would, one of the usually mundane aspects which is a supply chain. In particular, could you sort of address things like how much of your componentry was stuff that already existed? How much was sort of within a subcontractor's normal variation? And were there things where you said, I need you to develop this new thing? right? So that's often a challenge for new kinds of products. So that plus maybe some just-in-time type stuff or whatever, however you run the supply chain.
And let me just highlight what an important question is. Our CEO says probably every board meeting when our supply chain discussion comes up is it's very difficult to ship a car with only 99% of it.
The reason I asked is I happened to be there the day at the NUMMI plant where one big truckload of components was stuck down in LA and the whole place had stopped. So that's why I asked.
Yeah, we've unfortunately had a few of those for different reasons, but it's unbelievable how painful it is when you're missing one thing and the whole machine grinds to a halt. It's not mundane, actually, though. Supply chain is constantly rising in its importance and criticality to us. And we're throwing our best and brightest people now into supply chain problems and roles. Yeah. But what you asked about is very relevant, and we've kind of divided it almost into two different types of disciplines. The car components are generally well understood. When we're buying a seat or a tire or a windshield, there's a whole infrastructure and industry designed to supply those things. And then there's a lot of more of the kind of unique propulsion and electronic elements that are kind of new. We designed them and largely we're building them. Right. So we decided strategically, looking around, that there weren't any suppliers that knew how to make that stuff. So we could either train a supplier, how to make it, and then likely they would sell it to other people and competitors and kind of run off with the intellectual property, or we could just invest in our own team capability, build a production capability to do it. So that's why today we build our own electric motors, we build our own battery pack, our own chargers, almost the entire propulsion system we build ourselves.
And things that were sole sourced at one point where we didn't think the supplier could scale with the company. Team's done a phenomenal job vertically integrating and taking that in-house.
Yeah, and it kind of relegates the suppliers to more commodity items. Yeah. So we're not asking someone to invent a new charger. We're buying capacitors and PCBAs and heat sinks and small castings and machine parts. Right. So that's kind of how we've attacked that problem.
Yeah.
One of the things you pointed out is the need for the battery pack cost to come down, and the battery pack cost is made up of the cells and then the rest of the system. Mm-hmm. And like what we heard about in the PV, that the rest of the system can be a very dominant part in the cost equation. You guys went with cells that were already being mass produced, so there's Panasonic cells versus large format cells that some of the others wanted to go with. There's probably not a lot of room to wring out costs there. Roughly, what is the breakdown between the balance of system and the cell cost?
Yeah, well, we kind of guard that balance of breakdown between we guard that information a little bit. But I will say that it's...
But if you promise not to tell...
But it's different than the solar industry because the cells are a much larger percentage. So it's kind of like the solar industry several years ago, where you had the cell and the module being this sort of elephant in the room that everyone was focused on. I think we may see electric vehicles follow a similar curve where the battery cells do decline. There is a lot of room to decline on those things.
Panasonic's been making these lithium-ion cells since they commercialized them first in 1991. So they've gotten a lot of the economy of scale out of it.
Oh, but the price has been dropping massively through that time.
Every year the price drops.
It's not steady.
Yeah, every year the price drops, and there's a stated price drop over the next decade. Every year.
I think the curves that are published are not right. So we have a pretty detailed view into the battery cost. We spend a lot of time on it. There is a lot of room to move there, especially as the volume goes up. And that's something that I think also is pretty amazing if you look at the amount of production and the amount of efficiency that'll be gained as we scale up that volume. EVs today are less than 0.1% of the overall car market. The amount of growth is just phenomenal. Yeah. We're going to work for the next half a decade to get back to 1% of market share.
A question from the back of the room.
Actually, we have one right up here in front.
Okay, I'll go first. So you alluded to the fact that at some point in the future, we might see that the batteries on electric vehicles could contribute to sort of grid scale energy storage. Yep. And I guess, that's been something that's been debated, whether it's a good idea or not. There's also issues about, the warranty on the car, and, given that you might potentially be in both those businesses, so what do you think? I mean, is that something we should look forward to and anticipate, or is the risk to the automobile performance so great that you just won't go there?
Yeah, it's gotten a lot of attention and a lot of discussion on this, sometimes called vehicle to grid, different names for this. What I believe will happen first, and is still a massive opportunity, is managing charging. So aggregating and managing when and how fast charging happens on a massive scale. Vehicles basically are going to be a somewhat flexible load that we can move to wherever we need it to be, within time on the grid. And that, in a lot of ways, has the same effect as doing storage and then discharge. But I don't think we'll see vehicles discharging back into the grid. So it's conceptually a little bit different, but it massively simplifies the problem. You never have to worry about degradation on the pack. It had to get charged anyway. You just get to decide exactly what time and at what rate it charged.
The car is actually doing some version of that now. When I come home every day, I plug the car in, but I have it actually set to charge at 1201. Different cost per kilowatt hour. It can be done just with a simple software on the car already.
Yeah.
JB, back of the room, can we? The life cycle energy analysis that I hope some of your colleagues are doing for the production of this very special Model S at the current scale, plugging into the same grid, let's say, as GM and Toyota may be, those big battery packs, the special materials, and the salvaging or the recycling of all that. Has anybody done that, and how are you comparing right now to a Volt or a standard hybrid Prius?
Yeah, it's a great question. It's very relevant, and we are doing our best to kind of dive into that question. Our customers ask us all the time, and there's also a lot of great research actually happening at GCEP on some of those same topics. It's been a little more geared towards stationary at GCEP than vehicles, but the same battery energy, sort of embedded energy, is very relevant, and it still is quite positive. I think if you look at the direct comparison with a gasoline car, there's a lot of assumptions you have to make. First, as a disclaimer, you have to pick your kind of car, you have to pick what grid, you have to pick where your gasoline came from. Right. So these statistics and studies are very easy to be manipulated. And I think maybe not maliciously so, but you can have a very different outcome just by different assumptions going through it. And today, though, what we see kind of trying to make our best, honest approach through this is that, the electric vehicle sort of pays for its difference of energy, within, a few thousand miles, less than 10,000 miles. So you're basically, catching up and getting ahead fairly quickly. And this is not yet taking into account, what I think is a big, a very real part of this, which is the energy recovered when you recycle and remanufacture the packs at the end of life. We focus only on the battery for the most part. The rest of the car is basically equivalent. You don't need to worry about tires or interiors, and even the electric motor is kind of in a wash with a regular car. So if we just look at the energetics of what it took to make the battery pack, and then what energy savings you get by utilizing that battery pack over its life, that's how we attack that problem.
JB here. Hi. Tesla's gotten into the business of supplying battery packs and drivetrains to other vehicle manufacturers, which is a different kind of business to be in. But you also, I understand, are getting into stationary power. Could you talk a little bit about what that feels like? And we'll also note that there's a blogger who's commented that Sun City is the one who has selling more residential battery packs than anybody else.
You meant Solar City.
Solar City, yeah. Well, we did sort of branch out. We basically had a really core competency in these propulsion systems, and as we mentioned earlier, we build them ourselves. So we saw a nice opportunity along the way to partner and enable other vehicles and get the market moving faster. So we today are still building and selling full propulsion systems, batteries, motors, all of it to those partner companies. There's a new B-Class Mercedes coming out next year that has a full Tesla propulsion system in it. Another sort of branch of that is the stationary energy storage. And with the vehicle, our goal has been to drive down this cost per kilowatt hour, aggressively. And along the way, we've realized that we actually have reached a point where there's tons of very interesting economic opportunities on the grid, leveraging the same architectures of pack, the same manufacturing, the same supply chain. And we don't have to reinvent all of that. We can adapt it slightly. So, we've started, kind of quietly, but we're sort of testing the waters here. And with Solar City, we're developing and now building and selling a residential energy storage pack. It's about 10 kilowatt hours that pairs up with people that have solar. And it's predominantly a backup function. It doesn't do a whole lot of cycling, but it's there so that if the power does go out, you can still operate as your own kind of miniature grid, and you can use that battery pack to excite the grid and still get energy from your solar. Most grid-tied solar installations today don't do anything when the grid goes out. Everybody thinks they're off the grid. I'd say most people that get solar think they're off the grid, but in reality, they're quite dependent on the grid to use the solar. So this lets people leverage that. We're also doing commercial systems and doing multiple different scales of systems. Over time, I think that's an incredibly exciting market. And renewable energy is kind of bumping up against percent adoption caps in some small regions of the world, and it'll be larger and larger regions over time. So being able to solve how we get to essentially minimizing net metering and not using the grid as much of an energy buffer over time is going to be an important problem. And I think in the short term, it's there's a lot of debate about what the right percentage mix or where the theoretical maximum of solar or wind is on a grid. But in the long term, it's not 100%. You need to have some kind of storage there. So I think that's part of why we're so excited about it. We want to solve the whole picture of how do you get a solar-powered energy economy all the way through to your vehicle.
Yeah, over here. So I had a question about just sort of lithium sustainability. So even lithium isn't the most sustainable of resources, especially now that you guys are scaling up so much. So do you have any comments on the future of alternate power sources to lithium?
Well, I wouldn't worry too much about the lithium itself. There's a lot of lithium in the world, actually. Lithium gets talked about as kind of the resource constraint in many cases, but there's surprisingly small amounts of lithium in a lithium-ion battery. It's not a cost driver. It's not really a mass driver. There are actually, right now we're probably more concerned about nickel and cobalt. Those are far more prevalent elements in our battery packs than lithium is. So we track and look at more of the cost trends on those materials. Over time, though, the general idea of how do we find cheaper and more prevalent elements to go into the battery pack and energy storage system is the right way to think of it. But I think lithium can be with us for a long time. It would be nice if we could find other elements that didn't involve so much nickel or cobalt to store it as efficiently. So lithium sulfur is one battery pack that I think holds a lot of promise in the future. Has a lot of problems right now, but it does hold promise. And there you have two elements that are both extremely prevalent and very low cost.
Sorry, here. JB, you said that autonomous vehicles will come out for customers faster than people think. One of the biggest issues is legally and liability issues. What do you guys plan on doing on that, given that a lot of the liability is now going to be on the manufacturing company instead of than the driver or customer?
Yeah, it definitely is a challenge, and I won't pretend that we have some ideal answer to that, but I think that there are examples in industry of how that can get solved, with the appropriate level of understanding and sort of communication with the driver or the pilot. Airplanes, I think, are maybe one of the best examples where, with sufficient training and the right user interface, you can be quite clear about, where that handoff is and what's happening. But it is a big challenge, and it's something we have to pay attention to. It generally is. I think it shouldn't warp the technology direction too much, though. I think it's pretty clear to most people involved in Autopilot systems that you absolutely can make a safer car. There's just so much fear of even the 10 times safer car getting in an accident, and then people just blame it and then throw the whole thing in the garbage. So that's the right balance, and we need to figure out how to find that. I won't pretend we know the exact answer on how to do it yet.
So JB, I want to end by asking you one final question. You've proven yourself as a visionary. As you project out over the next decade, where is the world of transportation? How will EVs fit in? Just project out and tell us where we'll end up when we come back for the 10th annual reunion with this group.
Well, I think we will see more and more rapid growth of electric vehicles, and it's been very exciting to see how customers are adopting the Model S. It's really the first full function, ground up plug-in vehicle that people had a choice to make. And I think someone mentioned it earlier, but in Norway it's now the most popular car.
Yep.
And granted, there's some unique incentives and subsidies in Norway making that happen, but I think it's an interesting inkling of what can happen in the future.
Or just great taste.
or possibly that. But it's absolutely possible that we will have the majority of vehicles in regions becoming plug-in vehicles and becoming electric. And the exciting opportunities when you start matching that in a very smart way with a highly renewable intensive grid or low CO2 grid in those same regions is pretty cool.
Fantastic. So JB, I want to thank you for all the great work. I actually think 10 years from now we're going to be talking about some of the other great research coming out of GCEP that's now commercial at that point in time. So thank you, Sally, the entire GCEP team, and thanks for being here today.
Thanks, Ira. Thanks, Sally.